Okay, we're looking here at example 6.4. Now we're looking at a frame. Okay, so it says members ACE and BCD are connected by a pin at C and by the link DE. For the loading shown, determine the forces in the link DE and the components of the force exerted at C on the members BCD. Okay, so how do we do this? Well, first off, this is we can draw a free body diagram. We can figure out the forces at A and B, right? Let's draw that free body diagram right here. We're gonna have, oops, sorry, wrong button. Boom. We have this thing. We have a little pin here, but we're treating this as one rigid body, right? Okay, so here we have BX, and here at A, we're gonna have AY, and I can draw it because I'm pretty sure it's going to be this direction, AX. Okay, and we have our force here. But since we're treating this as, and this is 480 newtons. So we're going to do our sum of the moments about A is equal to 0. So what do we have? Well, we have 480 times this distance from here to here, which is 100, is equal to BX times 160. So BX ends up being 300, positive number, which just means we drew it in the right direction. Okay, and then we're going to take our sum of the forces in X equals 0, and that's going to tell us that AX is equal to 300. Again, we drew it in the right direction, kind of convenient. And then last one, we're going to take sum of the forces in Y equals 0, and that's going to tell us that AY is equal to 480. Yet again, in the right direction. So we were kind of smart in picking our arrows. So now we have our known forces. Okay, so now to the part that's actually being asked for. So why do we have to do that? Well, because we want to not have unknowns while we're doing the rest of these problems. Now we want to look at the member BCD. So let's just draw that member, right? We have this little thing right here. I'll even try to make it kind of with a little bit of depth. Okay, so right here we have 300 newtons going that way. At this point right here, this is point C, we have an unknown. So let's draw CX and CY. And then here at we have point D. Now here's the key. We have a DX and a Y, but it is not unknown. Why is it not unknown? Because look at this member. What do we know about this member right here? There are 1, 2 forces. This is a 2-force member in equilibrium. Therefore, we know the direction. And this, we're going to call that DE. It's a 2-force member, but it's a 2-force member in equilibrium. Therefore, we know the direction of the force has to go from D to E. So let's draw that triangle real quick so we can have that. This is going to be, here's our triangle. This is 80, 150. This gives you 170 is what you have there. Okay, so let's looking at this member. Let's do the sum of the moments. So let's say, scroll this up just a little bit. I'm going to say the sum of the moments about C is equal to 0. Well, you have 300 times the distance here. This is going to be 60, right? That's going to make it rotate in that direction, right? So I need to add plus DE times, now here's the deal. I got to break this into X and Y components. So I'm going to say the X component passes through there, so it's 0. So the DE and the Y times the distance from there to there, which is 250, is equal to 0. So DE in the Y is equal to minus 264. Okay, but we know what that is. This is equal to DE times the Y component is 8 over 17. So DE is equal to minus 561. Okay, so what does that mean? That's equal to, therefore, 561 in what? Well, we drew it in tension, and in reality, it's in compression. Okay, so now we have to figure out the first part. Determine this part right here, determine the force in the length DE. Well, it's under 561 newtons in compression. And so now it says we are supposed to figure out the components of the force at C. So we need to figure out CX and CY. So how do we do that? Well, we're going to go through here. I'm going to scum up here a little bit. We're going to say sum of the, whoa, That's not what I expected, sorry. Sum of the forces in, oh really? Sum of the forces in X is equal to 0. So we have 300, right? Plus CX is equal to DE in the X direction. Now again, this is where you need to be careful. So I drew the arrow like this. So what is this value for DE? So this is going to be, so CX is equal to DE in the X minus 300, right? So it's equal to, what is my DE? Well, it's minus 561. It's just a place ready to get you, because we drew the arrow in that direction, but with the arrow in that direction you have a negative sign. So it's minus 561 times 15/17. That's your X component, minus 300. And so that's going to tell us that Cx is equal to minus 795 newtons. So therefore Cx is 795. Just means we drew it in the wrong direction, in that direction. Okay, and then lastly, sum of the forces in y is equal to 0. So how do we do this? Well, we have, in this case, Cy is equal to dE in the, oh, whoa, we forgot a major one here. It hasn't affected us yet, but we still have this 480 newtons coming down there, right? So it's equal to dE in the y. I'm not sure why this is jumping, sorry about that. Plus 480, because the ups equal to the downs. But again, dE needs to be a negative sign, so Cy is equal to minus 561 times 8/17 plus 480, and we end up with Cy is equal to 216. So it's in that direction. It's a positive number, which just means we drew it right. Okay, there we go. That is our answer. We're done. We have determined the component. The member is in 561. This is in right here. This is in 561 newtons of compression. We figured out Cx and Y right there. So let's just do a little sanity check. Let's take this first member, which is just like this, right? It's this A to E. And what do we have here? We figured out this is a force. We have we have force here of 480, right? That's AY. We drew our AX in this direction, so AX is off this direction at 300. And then right here at point C, we just figured out the values. There's 795 newtons in this direction, right? No, this is where you have to be careful. That this member BCD, it experiences, we calculated these CX and CYs for that. So therefore, you have equal and opposite reactions. So in this case, you have 795 in that direction. And since CY was up here, you have, in this direction, you have the 216 newtons there. And then now it comes down to this force. Whoa. That was fun. It comes down to this one, and we have this member in compression, and this is DE, right? So again, we're not solving for anything. These are all known, which is this is equal to 561. So we're just, and I wrote it in compression on purpose, so it's not, we got rid of the negative sign. So let's just do a sanity check to make sure everything works out, right? So we'll take sum of the forces in X equals 0. So what do we have? We have minus 300 plus 795 minus 561. The X component of it is, where's my little triangle? Right here. It's 15 over 17, or 150 over 170 is equal to 0. And this does give you that 0 is equal to 0, so that's all good. And sum of the forces in Y is equal to 0. What do we have? We have 480 minus 216. In this case, it's going to be minus 561. The Y component of it is 8/17. And this does also show us that 0 is equal to 0. So it just shows us that we did get the right answer.